remember back, we're using your same formula, your same z-score formula. We didn't change your formula, but we said now instead of finding the z-score, we needed to find the x value. So we're going to cross multiply this guy and solve for x. So x is going to be equal to the mean plus the standard deviation times the z-score that we find. And sometimes they give us a percentile. Percentiles is area to the left, because your percents go from 0 to 100. So your percentile is always the area to your left. So we had to find a mean. We have a mean height. There's the mean with the standard deviation. There's your standard deviation. Which height, that's your x value, represents the 95th percentile. So you want to know what's that x cutoff score that's higher than 95% of the rest. So your area to the left is 0.95. You remember on your calculator we did inverse norm. Second there is number 3. Inverse norm, find your z-score. You can use your calculator to find your x value if you put your mean and your standard deviation in there. So if all I need is the x, you can just jump right to that if you wanted to. And I noticed some of you did, because I didn't see formulas, so I know you had to use your calculator. So just to review in your calculator, if you're looking for the z-score for this, first, second theirs. So we're pulling up a z-score. We want our area to the left to be 0.95. We paste. There's our z-score, 1.645. If you round it to 1.64, that's fine. Now, then you plug this into your formula. If you wanted to avoid this and cut right to this, all you have to do in your calculator is to go back to this guy and put in the mean, which is 64.2, and the standard deviation, which is 29, and let the calculator do the rest. And I saw some of you, whoops, I must have done something wrong. My board is not behaving for me today. 2.9, I put 29, sorry, 2.9. And so if you cut right to this, you'll get right to your answer. And rounding to this whole number or wherever you rounded to is fine. Okay? This avoids having to do that equation. Just remember, if you want the z-score, you're on the standard normal curve. Your mean is 0, your standard deviation is 1. If you want the x value, you have to put in your mean and your standard deviation. And I'm fine with that as long as you give me the sketch and you tell me calculator. The first quartile, there's your 25%. So I want to know what score is 25% area to my left. So same process. This takes care of, when you put your z-score in, the negative takes care of bringing it to the left of the mean. Is all coming back to you? Yes? Any questions? Okay. And again, a lot of this is a little repetitious, but I like these because they had a little variety. Some had to the left, some had in the middle, some had to the right, the top 5. This guy had the top 5%. Which one would put him in the top? The shortest time spent sleeping, that would still place a resident in the top 5% of sleeping times. So you're looking for this top 5%. If you want this to be 5%, then you're looking up 95%. If you looked up 5% and you got a negative, all you have to do is turn this into the positive, because your curve is symmetric. So everybody okay with that part? Finding that z-score? Top 5. Remember, your top 5 is up here. It's got to be pretty high up there. Between what two values does the middle 50% of the sleep time happen? Not from 0 to 50. Between what two values tells me this. This is where I want my 50% to be, right here. your curve is symmetric about the middle. So each part of this is 25, 25, so this is also 25. So I have to look up a z-score for 25% to my left. I find my z-score, I plug it in. I've got to do it for both of those. Find it for 25, and because this is not your plus or minus, it's plus or minus standard deviation, but not plus or minus an x-score. So do it with the negative, do it with the positive. And your calculator can do that also. Find each one for you. Okay with that one? That one's a little trickier. 50% in the middle. Okay. All right. Again, just watch your rounding. So let's take a look at it. This one doesn't look like it's rounded. So let's take a look. Oh yeah, they have decimals. Okay. What is the smallest annual per capita of apples that can be in the top 25%? Your top 25% is up here. So you're looking at inverse norm of 75%, or if you looked up the 0.25, and we've been seeing that one. You just saw that one right before this with the 0.25. Use the z-score. Don't look it up again. You have it already. 0.67. Okay, plug it into your thing. Now, here's the difference. Here is my z-score of 0.67. I want the top. If this guy falls at 11.38, and I need to round, and they have decimals, so you absolutely could leave at 11.38. If you wanted to round this to one decimal place to match theirs, where would I round? I'm here. I've got to be in this shaded area. So where do I have to round, regardless of what this number is? I have to round up into this. If I want to be in the lower part, then I'm going to round down into that. So watch your sketching where you round. So this guy would be 11.4. If it's down here in my bottom 15%, and my x value is 6.59, and I wanted to round down into this, I would have to round to 6.5. Because if I round up, I'm out of my shaded area. That's the only time you run into trouble with the rounding, is when we look at an x value. Good? Questions? So this is all good. Everybody's got this. All right. And this is the last one. No, two more. Okay. I want to be in the the upper. This is a great one to use for in the business world. The weights of your carrots are normally distributed with a mean of 32 ounces and a standard deviation of 0.36 ounces. Bags in the upper 4.5% are too heavy and must be repackaged. Why would they care? You're giving them too many carrots for the price of it, right? So that it's over the limit that they want to sell. If they undersell, you're cheating them. If you put too much in, they're cheating you. So this is really important. So they take a look at this. The 4.5%. So they want to know, where do I cut this off? Where do I allow this? How heavy should I allow this to be? So what is the most a bag of carrots can weigh and not need to be packaged? So the most it can weigh, it's got to fall beneath here. It can't fall into, once it falls into here, I got to repackage this guy. So find your cutoff. Now 4.5, when you make this a decimal, follow the same rules. Move it 2 places to the left. Your decimal is 0.045. Even though it had a decimal place, it was a percentage. Find your z-score, and the same thing. Okay, so, and again, you're going to have to round into this shaded area. Once it hits that shaded area, you have to repackage. Okay? So if this is my guy right here, now they had 2 decimals. Well, whatever your standard deviation is, that's where you could round to. That's a good rule of thumb. Wherever your standard deviation is, round to that. And you're going to see, like, you get more exact weights of bags, medical things, they get a lot more exact. They probably go 3 or 4 decimals. Good? Well, you guys are awfully quiet. All right, and this I think is the last one. Sell your automobile tires, and you expect they're normally distributed with you expect it to have a mean life of 30,000 miles and a standard deviation of 2,500 miles. And this is something that interests you guys. You want a guarantee for free replacement that do not wear well. You are willing to replace approximately 10% of the tires. How should you word your warranty? I'm the car manufacturer. I met the tire manufacturer. I'm selling these. I'm willing to replace 10% of my tires. Okay, so how should I word this? You will replace your tires if they wear out before a certain number of miles. Do I care about this if you go too long on your tires? Do I care about this end? I mean, there's 10% that sit at this end also, right? But do I care about this 10%? More power to them. Their tire lasted well more longer than it was supposed to last, right? Are these people going to come back and complain? No. So all I care about is these guys. That's the 10% I care about. It's my lower 10%. So I need to know where I'm going to cut this off. So instead of telling them I'm going to give them 10%, the lowest 10%, I got to tell them where, how many miles do you expect your tire to run, and if it doesn't run, will I replace it? So if it wears out before it hits that limit, then I should replace your tire. And that's how I'll word my message. I don't care about these guys up here. They did great. They're well above the mean. They're not going to come back and complain to me. It's these guys over here. You buy a tire that lasts 30,000 miles, and you come in and you say, I only have 20,000 miles on my tires, and my tires went. Isn't that a concern? So I as when I'm selling this, say, well, I expect them to be 30,000, but does every tire be 30,000? No. So I say, well, okay, 10% puts me here. I'm okay with 10%, losing 10% of these. So if your tire wears out before it hits 26,800 miles, I will replace your tires. Free replacement. Okay? It's a nice way for you to check your tires. And you always should look for something like that. So are we okay with this? And again, you have to watch, where does your percentage come? Does it come at the bottom? Does it come at the top? Does it come evenly in the middle? If you hear ones that say the middle 50%, the middle 80%, the middle means it comes exactly in your graph, and whichever on the ends have to be the same, because your curve is symmetric. And then you find your plus or minus z-scores, and then you find your x values to match those. You can always do a plus or minus z, but you can't do a plus or minus x. So the x's you have to find separately. So we're good with these?